And welcome everybody to the Daily Space Weather. Another exciting episode here. Lots of stuff going on. Sunspots, a coronal mass ejection glancing blow, and solar cycles. And by the way, being right is rarely glamorous. So we're showing you the sun here, the local yellow dwarf, El Sol. And we're showing you colorized magnetogram. We've got two sunspot groups in the northern hemisphere. Sunspot 2811 would be this one, and sunspot 2812 would be this one. The former is beta class, increasing the probability for solar flares a little bit. The former is beta class. 2811 is beta class. 2812 is alpha class. So 2812 is the largest umbra on the Earth-facing disk, and the most likely place to see coronal mass ejections is sunspot 2811. So here's another full disk view in 304 angstroms ionized helium. And yeah, some interesting physics going to come out soon, folks. We'll only briefly touch on it in today's Daily Space Weather video. It'll have to be a cosmology segment at a later time. So here's 94 angstroms, a full disk view. This is one of the ionized emission spectral states. It's UV light produced by ionized iron. Lovely emerald green coloring there. Here's 171 angstroms, one of the crowd favorites, and my personal favorite wavelength. Another ionized state of iron. And we'll talk about stellar metallicity at a later time. Here's a close-up of sunspot 2811 and sunspot 2812 in 193 angstroms, yet another ionized iron UV emission spectral state. And we'll show you more close-ups of those sunspots at the end of the video. Stay tuned for that. We're going to blast through a whole bunch more data. So we see some anomalies here on stereo A. We'll show you in a moment. First, a diagram of the solar system. There's where things will be in a week. And let's bring this back to today for demonstrative purposes. Stereo A is located about here. Stereo B is located about here. And check out the view that we see from stereo A. This may strike your fancy. You may find this to be interesting. We've got an anomalous object over here. You can see the way it's clearly moving right to left. So let's go back to our planet diagram here, just to show you what we're talking about. So stereo A is located about here, and it's moving right to left, which means if it was a planet, it would need to be on the sun side as the planets rotate in this direction. And we don't see any planets on the sun side, which means that's not a planet. If it were, it would be moving in the opposite direction. So again, there's that view. Not sure if that's a comet or what that is. Leave us a comment if you have a theory. Next, a star chart. Here's in-the-sky.org. And if you're up before dawn, you may see Saturn rising ahead of the sun. I like to face my star chart to the south, as I'm currently facing the south. And this yellow line here is the ecliptic. You can see the moon just about to set here from the perspective of eastern Pennsylvania. We're in the Lehigh Valley. The 10.7 centimeter radio flux, the radio output of the upper chromosphere and lower corona, is at 84 solar flux units, also known as the 2800 megahertz radio flux. The 10.7 is the most proportional data set to sunspot number. So here you can see sunspot number on the red line and radio flux on the black line. It's a one-year chart from solon.info. And I would note the incorrect forecast here. So the glancing blow from the coronal mass ejection if that even was a coronal mass ejection, it had some of the properties of a coronal hole wind stream signature. We did not see this spike in the solar wind density. So basically, the coronal mass ejection strike was a complete dud, unless it was mistimed, as we didn't see any density spike. And we'll show you more on that later. First, some volcanoes. What's been erupting? Well, Fagradalsfjall is currently erupting. We'll show you some real-time footage of that. Klyuchevskoye has been returned to its green warning level. So aviation color code now lowered to green as it has stopped its effusive explosive activity. Abiko, flight level 070 above Abiko, it's a 7,000-foot ash plume. Sakurajima, 8,000-foot ash plume. Suwanosejima, 6,000-foot ash plume. Mount Raung exploding. Flight level 150 above it, the East Javan volcano producing a 15,000-foot plume of volcanic ash. No significant eruptive activity at Veniaminoff, located on the Alaskan Peninsula. Popocatépetl exploding, 19,000-foot ash plume above the central Mexican volcano. Two volcanoes erupting in Guatemala, Pacaya and Fuego. Pacaya producing a 12,000-foot plume of volcanic ash, and Fuego has dissipated its volcanic ash, according to satellite imagery. Sangay and Revenador, both erupting in Ecuador, 20,000 and 16,000-foot ash plumes, respectively. There, Sabancaya exploding, 24,000-foot ash plume above the Peruvian volcano Sabancaya, and Soufrière on Saint Vincent has a growing lava dome, folks. It's continued to slowly grow for the past week, expanding in the north and south. A team visited the dome to make observations, take measurements, and maintain monitoring equipment. Gas and steam continue to rise from the top of the dome as well as along the contact between the old and new domes. So the alert level remained at orange for Soufrière on the West Indian Isle of Saint Vincent. There's an article, by the way, which you can link to from this volcano discovery page about Fagradalsfjall. This link right here. We'll link you to this article from Volcano Cafe. And I'll just allow this to scroll for all of you viewers who like to pause our videos and read articles. Great article about the evolution of the 4 different cinder cones at Fagradalsfjall, the Icelandic volcano. Thanks to Volcano Cafe. And here is the current situation. It's a live feed. And let's all take in the pristine beauty of Iceland and the currently erupting volcano of Fagradalsfjall. Fantastic. And of course, it's a little more spectacular at nighttime, as a lot of this lava here in this lava field is actually emitting light, but it's not visible during the daytime. I believe they've actually got legit audio now. They were playing a loop before, so check that out. We'll share that as a community post. In fact, let's share it as a community post right now as we stream live. By the way, welcome to the Neo-Renaissance, folks. Please visit our own website, smAsho.com. We saw the writing on the wall years ago for what was going on the internet with things like censorship and nonsense and fraud. So visit that. And don't forget to click on the link on our homepage, this one right here, the smAsho merch link. You can still save 15% on any orders from our Redbubble shop by entering the code MAGIC15 on checkout. Save 15% by entering the promo code MAGIC15 on checkout at our Redbubble shop. Check that out. There is a volcano-themed product. It's our Do Not Pole Vault the Caldera design. And we would remind our viewers to please not pole vault the caldera. Here at the Smash News Network, we consider that to be irresponsible behavior. And so we try to discourage people from doing stupid, idiotic, moronic mentally handicapped things. And let's continue on. Have you seen our COVID Chronicles Then and Now videos? Well, I have one thing to say, and that is, shut up, Fauci. Fauci, shut up. More on that later. Did you watch yesterday's COVID Chronicles video? Well, there's a playlist at youtube.com/smAsho/playlists, and you can also find a lengthy forum thread. By the way, happy birthday to Granddad, who turns 93 years old today. Happy birthday to Granddad. And we'll make another COVID Chronicles video today featuring some more interesting information. Let's get back to the geospace. Earthquakes over the past 24 include a 4.4 magnitude quake at around Fiji at nearly 400 kilometers depth. Also a deep quake in western South America here, this one at Argentina, over 225 kilometers depth. So no major quakes over the past 24. Here's another deep quake, this one happening in Indonesia, over 570 kilometers depth and a 4.9 magnitude. And just continuing up the list here, 4.4 magnitude quake at Colombia at depth, deep quake at Russia. So lots of deep quakes happening, folks. Here's another, I think the largest of the past 24 actually, a 5.5 at Fiji, nearly 600 kilometers depth on that one. A deep quake at Chile, a 4.0 at 115 kilometers depth. And continuing on, we saw one significant solar flare here. The peak flux was around 2150 yesterday on the 24th, a mid-level B-class solar flare. No proton strikes showing up on the GOES, and no surprises there. By the way, I would note that we did not forecast any coronal mass ejection strikes, just a glancing blow, if anything, and there is the proof of that, unless it's much, much more slow than was forecasted. Here's the GOES magnetometer over the past 3 days, and we're seeing spiky readings here. As there's been quite a bit of plasma in between Earth and Sun, there is a giant electron bridge in between Earth and Sun also. We'll get to that after the cosmology segment. Next, looking at more magnetism, here's the polarity of the heliospheric current sheet. And before I continue on with that, let me just check the life of the stream here. And everything looks copacetic. Or should I say kosher? Or is that too controversial? So here's the top view ecliptic plane field plot. It's showing you the polarity of the material in the current sheet as one of the solar polar fields charges it up. You can see the Earth is solidly in the South Pole current sheet. There is some significant possibility for additional coronal mass ejections. We'll keep you posted on that. And you can see the North Pole current sheet coming through here, this green region, a couple days before the Earth is likely to snap into that. Here's another view of essentially the same data, which is gathered from 51 ground-based magnetometers. It's part of the National Sunspot Observatory, as well as magnetometers on stereo A and stereo B. Speaking of B, there's the Sun's B field shown in blue. And you can see some coronal holes there, mainly South Pole-oriented ones, some North Pole-oriented ones coming in along with the North Pole current sheet. And here are some more views. It's the magnetogram with the detected sunspot groups and detected filaments. So we see some filaments continuing here to show up around the eastern limb. Again, likelihood of some additional coronal mass ejections is still there, folks. And you can see sunspot 2811 and sunspot 2812, 2811 beta class, sunspot 2812 alpha class, having only one polarity, umbra. Geomagnetism on the global scale is currently in a state of geomagnetic unrest, having reached geomagnetic storm conditions with a sudden spike in the solar wind speed happening early this morning. A brief period of geomagnetic storm G1 class KP5 shown there on the graph. Next, the real-time solar winter. We're going to show you this little spike here. We saw a spike in the solar wind speed. Do you see a spike in the density, folks? No, not in the slightest. Anyway, current conditions are solar wind density around 10 protons per cubic centimeter, solar wind speed 411 kilometers per second. Next, we'll show you 2 geospace magnetosphere movies showing you the magnetohydrodynamic density, the density of the incoming solar protons here. And yeah, protons per cubic centimeter is the units of this particular 4-hour animation. And you can see quite steady density here over the past 4 hours. We'll also show you pressure, and we're expecting to see pretty high pressure during a period of geomagnetic unrest. So fairly high pressure, but also fairly steady over the past 4 hours. Next, we'll show you changes in the Earth's B field. By the way, this is showing you the Earth's B field as well, especially the meridional plane view. So here's geospace delta B, showing you changes in the Earth's B field, otherwise known as geospace delta B from the poles. This will also give you some idea of where auroras are most likely to happen. And since that refreshed, we're going to advance that. There we go. It's about 4 hours of data once again, folks. We show it daily because this data archive is not yet publicly accessible. Here's the global view, the flat Earth map. And please leave us a comment if you believe the Earth is flat and that space is fake. We won't censor you, but we might berate you publicly, so don't make a fool of yourself. We are free speech advocates. And Fauci should still shut up. Next, looking at twitch.tv/smAsho, where we're currently streaming. We don't always stream to Twitch. It's a great mobile streaming platform. Sometimes we stream live to YouTube as well. Thanks to our viewers on both platforms, as well as our viewers on BitChute. We've got exclusive content there. Did you see our March 19th, 2020 video entitled COVID-19, the disease caused by coronavirus cured via hydroxychloroquine and azithromycin? Maybe, maybe not. Let's do a cosmology segment. And this one's going to be pretty short and pretty sweet. First, let's thank the true stars of this production, our patrons. Please consider becoming a patron at patreon.com/smAsho. Thanks to our patrons, we put their names in lights. And by the way, in April, we'll be doing a contest to give somebody a free month at the lowest tier in Patreon. Again, patreon.com/smAsho. And let's talk about some magnetic fields. So, our viewers may be very familiar with M87, the quote, black hole, end quote. And what we're looking at here is polarized light emanating from the torus, which surrounds the massive radio source at the core of galaxy M87. Why? Because polarized light gives us insight into the potential field surface source lines, the magnetic field lines coming from the massive radio source at the core of M87. And you can see the way that these protrude out of the central region. Probably no real surprise there. If you want to read more about it, have a look at this article. This one's from SciTech Daily, although it'll be all over the Science Wire. The magnetic fields at the edge of M87's massive radio source. I try to not refer to black holes as black holes, folks, because since the mid-90s, I noticed that some folks, enlightened astronomers, were referring to, quote, black holes, end quote, as massive radio sources. And you can see some insight into the magnetic field lines in the jet of M87. Very interesting. And we use polarized light and radio interferometry. To get this, it takes quite a lot of work. Thanks to everybody who contributed to this data set. fascinating insights into the magnetic field force lines of the jet. So a fantastic piece of data here for all of you interested in cosmology out there. The potential field surface source lines, the magnetic field force lines of the jet at Galaxy M87, and the massive radio source located at its core. Let's pick a random number using our quantum random number generator here between 1 and 1031 to pick a quote random end quote object at the Neil Gorell Swift-Bat X-ray Observatory. This one's easy to remember. It's number 999. And if you go to the Neil Gorell Swift-Bat X-ray Transient Monitor, BAT stands for Burst Alert Telescope, and you scroll all the way down toward the bottom of the list here, you'll find number 999 is Galaxy NGC 7213, a Seyfert 1.5. And allow me to correct myself. I said something wrong about BL Lacertae objects. BL Lacertae objects are not flat spectrum quasars. BL Lacertae objects are specific spectral emitters, not flat spectrum radio quasars. I got those mixed up. I apologize. BL Lacertae objects, again, different than flat spectrum radio quasars. Flat spectrum radio quasars produce a full spectrum of electromagnetic radiation. BL Lacertae objects have specific spikes in their emission spectra. So here are the emission spectra from Galaxy NGC 7213. And it's a Seyfert 1.5, which is a type of active galactic nucleus. And it all has to do with our perspective. A Seyfert 1.5 galaxy, folks, is a galaxy where we're not looking quite directly perpendicular to the galactic plane. So here's the let's say here's the jet field. A Seyfert 1.5 galaxy would be looking at it sort of from this angle, where it looks kind of bright, but not blazar bright, as if you were looking from this angle. Does that make sense? I hope that makes sense. Anyway, let's take a visual of NGC 7213. You can see it's a fairly variable X-ray source. Here's the 30-day chart of its X-ray transient outbursts. And just give it a minute to load here. We'll bring up Aladdin Light, and we'll show you a couple wavelengths. So this one actually looks like an ellipsoid galaxy. We don't see any sort of indication of spiral arms here. Maybe a little bit. I see a slight indication of a dust lane right in this area. And let's take a look on the 2MASS, which may give us some additional insight. There's the 2MASS, which is infrared light. Let's take a look at pan-stars, which is a series of optical bands, and it's not on pan-stars. How about in blue light? May give us some additional insight. And we do see some spiral features here. You can see this dust lane as well as a dust lane right there. So some indication of some spiral arm patterns. How about on Chandra? And there it is on the XMM multi-mirror project. It's Galaxy NGC 7213, folks. Today's featured quote random and quote object in today's cosmology segment. And if you enjoy the cosmology segments, don't forget to press like and subscribe on YouTube. And let's get back to some electronic sort of data. Yes, electronic data, folks. Here's the one-year chart of the relativistic electron flux as reported by Solon.info. And here's the 3-day chart. And we see a fairly moderated range here of electron flux. Nothing to write home about there. We show it daily anyway, as it has to do with the power of the dark side. The power of the Van Allen belts, folks. So here's the forecast. And I would actually disagree with this forecast, especially this box here. The green boxes are the forecast, folks. I think this is going to actually be higher than this. And without further explanation of that, let's take a look at the visualization of the inner Van Allen belt. GPS satellites orbit at about 12,500 miles of altitude, 12,500 miles of altitude for GPS satellites. And that requires them to communicate through the inner Van Allen belt. Here's a visualization of that. And you're most likely to see GPS errors around the equator at noon. It's the total electron content forecast. And we see a little bit of disorganization here where we see some slightly higher electron flux at nighttime. Nothing too extreme. We do see more anomalies in the total electron content during low levels of electron flux than during electron storms. During electron storms, the inner Van Allen belt is much more organized than during low levels of electron flux. Next, looking at a diagram of the atmosphere, and we show this daily to show you where the F layer is. And the F layer is right around here, around 300 kilometers of altitude. That's where the GOES 16 endeavors to make its measurements. And here is the F2 ionosphere layer, the F ionosphere layer. When you see a red blob, that layer is the F layer. And the yellow would be the F2, and the olive would be the F3, and the green would be the F4. I hope that makes sense. The D layer would be 2 shells below in altitude. And we do see some anomalies here over places like the Central Pacific Ocean, actually. Some very odd charge-ups happening there. We're talking about this area over here. And if you want to look up this data yourself, it's from the Australian Government Bureau of Meteorology. Some discharges there happening on the nighttime side as well, over places like the North Atlantic, Greenland, and northern Canada. Let's bring up the latest image. Latest image here is from 9:30 Universal Time. Next, we'll do some meteorology stuff. Here is the jet stream scenario for the eastern world. Let's take a look at surface winds real quick as we see an anticyclone in the southwestern Pacific. Let's see if it translates to surface winds. Not really. Anyway, there are the surface winds. And we'll go back to the jet stream and rotate planet Earth. Here are the jet streams of the western world. And we see some extreme cold air being injected into the northern Rockies here with this meridional jet stream flow. Cooling off some of the hot air emanating from Colorado. Next, how about pressure maps? I would note the entire South Geographic region, the South Polar Geographic region, is completely covered with low pressure. You can see entirely low pressure down here at the bottom. Keep in mind, this is the flattened map. And we'll advance this into tomorrow. Here's where the Euro forecast has pressure at noon tomorrow. Let me just slide that back. There we go. Give that a minute to load. This is the pressure movement. And continuing on, how about lightningmaps.org? I like to use lightningmaps.org when I hear thunder. It could save your bacon, and we've got some significant storms here in the south central U.S. South Central has put Dallas to the test. Texarkana, you're surrounded by lightning storms. Hey, Mount Pleasant. Hey, Mount Vernon. There's thunder rolling in. Anyway, there's your real-time lightning map. We'll zoom out to the global view, and we'll switch to the U.S. Doppler radar. Here's a U.S. Doppler radar map, folks. And you can see heavy storms here over eastern Texas, most of Arkansas, Mississippi, and Alabama, and those are moving to the northeast. And let's see if we can give you an idea of how fast they'll be moving. A bunch of snow in the northwest as well, by the way, folks. Here's the cloud layer over the lower 48. Give it a minute to load. Again, we are streaming this one live. And we've bound up like somebody who eats only cheese. All right, here we go. It's the lower 48. Shortwave radiation map, 3.9 nanometers. Let me speed that up. I don't know why it's going so slowly. Come on, Micro Sloth. All right, there we go. So there's what's going on in the cloud layer. Here's what's going on in water vapor. And as you can see, this dry mass of air here is taking its good old time getting a move on. And that's why those storms are moving so slowly in eastern Texas. In fact, all this moisture is taking its good old time, as there is no dry mass of air input to speed it up. And basically the movement of this high pressure front will be in charge of the speed at which those storms move. And we've got bonus features for you, folks. We're going to show you the most current image here, the hydrogen alpha animation from, once again, El Teide, Spain, the ground-based observatory. Give it a minute to load. And what the heck is that? That is not what we were looking for. And just bear with me while I figure out what's just happened. All right, I must have clicked on it instead of pressing play. And here's the latest data from El Teide. And you can barely even see the sunspots on this view, so let's continue on to show you what I saw during show prep versus what's going on now. So when I did show prep, and again, let me just check the life of the stream to make sure we are good, and we are indeed just fine. So here's the colorized magnetogram, and here's the intensitygram. Let me refresh this one as it refreshed on its own. So thanks a lot, SDO site, for that. Let me move that up a little bit. I think we've got old data here. I don't know what's going on with refreshing today. It's not refreshing the way it's refreshing. So it's the dangers of streaming live, folks. But in any case, there is the current magnetic field situation. Come on now. There's the magnetic fields in colorized magnetogram. And it looks like sunspot 2811 has actually degraded a little bit. The trailing umbrae here have shrunk. Again, there is still significant possibility for some coronal mass ejections as well as solar flares, especially solar flares from 2811, which is this leading group right here under my pointer. So here's 94 angstroms. We'll also show you 131 angstroms and 171 before we close this thing out. Here's 131 angstroms, another ionized emission spectral state. UV light in a very specific bandwidth from ionized iron, folks. And these are all false color, by the way. The human eye cannot see UV light. Those aqua colors are artificially added. And last but not least, here's 171 angstroms. Thanks again for tuning in, folks. By the way, we'll be explaining the mechanism behind the sunspot cycles soon. Our patrons would already know about this, thanks to especially gold and condensed matter to the 9th power tier patrons, as we already sent you 2 papers about that. And thanks again for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink, and if you do, don't drive. Seriously, don't drive. And since it'll never be now again, may that solar wind be at your back.